Really, how to find outliers. Look at the following quiz scores for Sally and Timmy. And it says, without using a calculator, which student will have a lower average quiz score? You know, average is when you add them all up, divide by how many they are. The first thing that pops out, Timmy had a tough day this day. I don't know what happened, but all the other quiz scores are the same, right? Pretty much the same student. Maybe Timmy had a bad day one day. It is what it is. So which student would have the lower average quiz score? Timmy would have a lower average quiz score, right? Because of that 30. Everything else is the same. 30 is less than 80. How can you tell without a calculator? Everything that we just said. What's the median for Sally? Well, the median for Sally is what? Not those, not those. It's that one right there. And it would looks like it would be 90 for both Sally and Timmy. So what can we take away from this? The median isn't affected by crazy numbers. Okay, the median is going to stay the same, but the average or the mean is affected by crazy numbers. Okay, that 30 was what we're going to call a crazy number here in just a second. And that 30 affected who won or lost the lower average. Okay, did not affect the median. Next one. Same quiz score, same people. Poor Timmy had a bad day. Sometimes when we have a list of numbers, we'll have a number within a set that differs greatly from the rest of the set. It differs greatly from the rest of the set, and we call that number an outlier. Outliers are extreme values that differ greatly, there it is again, from the rest of the set of numbers. What does it mean to differ greatly from the rest of the numbers? Well, our definition is a data value is an outlier if it is more than 1.5 times the IQR below Q1 or above Q3. I don't necessarily expect you to memorize that. I expect you to be able to recognize that and for it to help you maybe trigger something in your brain to be like, oh, yeah, I remember what to do, because somewhat tedious task in front of us right here, okay? So, got to find some outliers. When I look at these, you know, I don't know what these numbers represent in life, where we got these numbers from, but is there a number up there that looks like it differs greatly? No. All those numbers, you know, the numbers on the outside, 3, I mean, that's pretty close to 5 and 6 and 7. 17, it's pretty close to 15 and 16. Like, there's no number that looks like it differs greatly from the rest of them. So let's show that mathematically that there are no outliers on this one. So let's find the IQR. Whoa, well, I got a box and whisker for you right here, right? That helps out. You know, the IQR is Q3 minus Q1. What's Q3 up there? Q3 would be 15. Minus Q1 would be 5. So my IQR is 10. And I'm going to take that 10, that IQR right there, and I'm going to multiply it by 1.5 times 10, that number that I got right there. And 1.5 times 10 is 15. So that's a magic number that I'm going to add to Q3. Q3 is right there. I'm going to add that number. And then from Q1, I'm going to subtract that number. And I'm going to see if anything falls outside of those numbers. So Q1 was 5. And let's subtract that number we just got, 15. That would be negative 10. Q3 is 15. Let's add the 15 we just got. That would be 30. Now, negative 10 is like way over there on the number line, and 30 is like way over there on the number line. Are there any dots or box and whisker stuff over there past those two numbers, negative 10 and 30? No, there's not. It's all in between here. So there are no outliers. Next one. If I'm eyeballing this one, maybe 1. I mean, 19, it's really close to 18. There's 2 18s, but 1, I mean, it's a little bit of ways from 10 there. So let's try it out. Whoa. Problem here. What's the problem? There's no box and whisker plot. So a couple different ways to go about that. I mean, you could, you know, find the median. You can find the Q1, all that kind of stuff, I'm just going to punch it in right here. And I'm going to say 1, comma, 10, 14, 14, 15, 15, 18, 18, and 19. There's 9 numbers in my list. And over here there was 1, 2, 3, 4, 5, 6, 7, 8, 9. Sweet. So if I want to find the IQR, that's Q3 minus Q1. How do I find Q3 minus Q1? I got to find the stats of that data set that we just had. So stats of A. IQR, Q3 minus Q1 would be 18 minus 12. That is 6. Okay. So 1.5 times that number we just got, 1.5 times 6 would be 9. And 9 is going to be the magic number that I add to Q3 and subtract from Q1. So what was Q1? Q1 was 12 minus 9. That would be 3. Q3 was 18 plus 9. That's 27. Is there a number? So is there a number to the left of 3? Well, yeah, 3 would be right there, right? So yes, there is an outlier. 1 is an outlier. Is there a number to the right of 27? Well, 27's over there. There is not a number to the right of 27. So 1 is the only outlier. Okay? You could have outliers on both sides. In this case, we only have 1 outlier. What does that look like? Well, when I have a box and whisker plot, if you look up top, that's what we would have done. We would have put the minimum. We would have put Q1. You know, the minimum's right there. The Q1, median, Q3, and maximum are right there. We draw the really long whisker right there. The problem is when you have an outlier, it doesn't really reflect what the data is. If there's one number way over there, in general, we put a dot there or an asterisk. Ooh, that was a bad one. That's even worse. Kind of like that over here where that dot is. Either one of those will work. Okay? Now, what to, I got to erase those. Those are like killing me right here. So, when I have an outlier, I put the dot or the asterisk over there, and that allows me to say, hey, all this data over there, it really reflects what's going on. There's an outlier over here. We don't want to, leave it off the graph, but this stuff on the right side really reflects the graph. This graph up top would mean that, well, we don't know. We might have a lot of numbers within that range. This down here shows us that there's only one number over there. I got an IQR right here. All right, I don't want to do this by hand. Gonna come over here. A equals brackets, and inside the brackets, I'm gonna type all these 2, 9, 14, 17, 20, 22, 32, 34, 42, and 99. And the function that is going to give me my Q3 and Q1 would be stats. Q3, it says, is 34. Q1 is 14. My IQR is 20. So, 1.5 times that IQR I just got would give me 30. You would punch that in the calculator. And then I'd have Q1, that would be 14 minus 30 is negative 16. And then I got Q3 is 34 plus that 30 we just got, which would be 64. Now, negative 16 over here. That would be over here somewhere, negative 16. Is there a number to the left of negative 16? No. 64 would be right there. Is there a number to the right of 64? Yeah, what is it? 99. So 99 is the outlier. So, 5-number summary. I would normally have 2, or are these going up by 2's on the bottom? I have 2 right there. And then I'd have 14 right there. And I'd have 21 is my median right there. Q3 would be 34 right there. And normally I'd go all the way to 99 over here. But I'm just going to make a dot right there for 99 because it's an outlier. So, since I did 99 for an outlier, I'm going to put another line over here at 42. So my box and whisker plot will look like this, with 99 as my outlier way over here and all of my data being right there.